Okay, so good morning, grade 11 students. Ayan, so today is February 10, Wednesday, and today we will discuss about regression analysis, particularly on predicting the value of a dependent variable and solving problems involving regression analysis. So first, I would like to share to you our Bible verse of the day. So it can be found in Psalms chapter 37 verse 4. So it says that delight yourself in the Lord and He will give you the desires of your heart. So we are on the last topic of our module, so on module 23 and 24. So this will be our final lesson in statistics and probability. Okay, so the first sem is almost comes to an end, and I hope that you learned a lot from this subject, statistics and probability. Okay, so today, as what I have said a while ago, we'll discuss about regression analysis. So here are the objectives for this lesson. You must be able to calculate the slope and y-intercept of the regression line, predict the value of the dependent variable given the value of the independent variable, and solve problems involving regression analysis. So what is a regression analysis? It is the field of statistics that deals with prediction. It is the process of estimating a functional relationship or of using statistical methods to obtain an equation between a random variable y and a non-random variable x. So we have the so-called linear regression. So, of course, in a linear regression, we have there a straight line, wherein it is called a regression line. It's also called a line of best fit. And a regression line or line of best fit is the line for which the sum of the squares of the residuals is a minimum. So, the equation of a regression line for an independent variable x and a dependent variable y is equal to bx plus a, where y is the predicted y value for a given x value, b is the slope, and a is the y-intercept. And we have here below the formulas for slope and y-intercept. So for the slope, we have the formula n, or the sample size, times the summation of xy minus the summation of x times the summation of y divided by the sample size times the summation of x squared minus the square of summation of x. And for the y-intercept, denoted by a, we have the formula summation of y minus the slope times the summation of x divided by the sample size. So take note of these formulas. So, steps in regression analysis or in determining the regression line equation. First is, we need to find the value of the sample correlation coefficient, or what we call the R value. Of course, before finding the value, you need first to formulate the null and alternative hypothesis. And then number 2, test the significance of R. If R is significant, you will proceed to regression analysis or proceed to step 3. But if R is not significant, so regression analysis cannot be done. So you need to stop. Number 3, find the values of slope and the y-intercept, or B and A. And number 4, substitute the values of b and a in the regression line equation. Y is equal to bx plus a. So let us have this example. The following data shows the number of absences and the number of quizzes missed by 5 students. If there is a significant relationship between the two variables, predict the number of quizzes missed by a student who was absent for 6 days. So for the number of absences, we have 1, 1, 2, 3, and 4. And the number of missed quizzes, we have 1, 2, 4, 2, and 4. So let us first formulate the null and alternative hypothesis. So for the null hypothesis, there is no significant relationship that exists between the number of absences and the number of missed quizzes. And for the alternative hypothesis, there is a significant relationship that exists between the number of absences and the number of missed quizzes. Next is for us to compute for the R value. Of course, we need to have this table. So for our values of x, 1, 1, 2, 3, 4, values of y, 1, 2, 4, 2, 4, then we need to have x, y. So we just multiply each entry on x and y. So 1 times 1 is 1, 1 times 2 is 2, 2 times 4 is 8, 3 times 2 is 6, and 4 times 4 is 16. Next, we need to square the values of x. So 1 squared is 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And for y squared, we need to square the value of y. So we have 1 squared is 1, 2 squared is 4, 4 squared is 16, 2 squared is 4, and 4 squared is 16. And then get the sum or the total of each column. So total of x is 11, total of the values of y is 13, total of the values of xy is 33, total of the values of x squared is 31, and the total of y squared is 41. So we will just substitute the values of the given sum in our formula R. So R is equal to the value of n is 5 times the value of summation of xy is 33 minus the value of summation of x is 11 times the value of summation of y is 13 divided by, so n is 5 times summation of x squared is 31 minus square of summation of x, so square of 11 times n is 5 times summation of y squared is 41 minus the square of summation of y, which is 13. And we have R value is equal to 0.63. So we will just round off up to 2 decimal places. Next, after solving for the value of R, we need to test the significance of R. So we can use t-test or z-test. You will use t-test when n is less than 30, and you will use z-test when n is greater than or equal to 30. And we have the formulas for t-test and z-test. So on our example, since our n is less than 30, because it is equal to 5, so we will use t-test. Okay? So, applying the formula, t is equal to r times the square root of n minus 2 divided by the square root of 1 minus r squared. And the degrees of freedom is equal to n minus 2. So, substitute now the values. So, t is equal to value of r, which is 0.63 times square root of n is 5 minus 2 divided by the square root of 1 minus the square of r, which is 0.63. And our degrees of freedom is equal to n, which is 5 minus 2. So, degrees of freedom is equal to 3. And then calculate. So, we have t value is equal to 1.405. And if we set the alpha level to 0.05, so we can get the critical t value of positive negative 3.182. So, the degrees of freedom is 3, and it is a two-tailed test at 0.05 level of significance. So, on our t table, we have positive negative 3.182 as the value of our critical t. Next is to decide, make a decision. So here, if we will compare the computed t-value by the critical p-value, so we can say that 1.05 is less than 3.182. Since it is less than, so meaning we fail to reject the null hypothesis. So our decision would be, since the computed t-value of 1.405 is less than the critical t-value of 3.182, the null hypothesis is fail to reject at 5% level of significance. And since we fail to reject the null hypothesis, so meaning there is no significant relationship between our dependent and independent variables. And because there is no significant relationship, so meaning we cannot do the regression analysis. So our interpretation, although the computed R value of 0.63 indicates a moderately strong positive correlation between the number of absences and number of missed quizzes, further test nullifies this finding. The test of correlation shows that there is not enough evidence to reject the null hypothesis, that there is no significant relationship that exists between the number of absences and the number of missed quizzes. And in our conclusion, therefore, there is no significant relationship that exists between the number of absences and the number of missed quizzes at 5% level of significance. Hence, the number of quizzes missed by a student who was absent for 6 days cannot be predicted. So, we cannot make a prediction since no relationship exists between the number of absences and the number of missed quizzes. So, meaning we cannot do the correlation analysis. Okay? Let us have another example. The following data pertains to the heights of fathers and their eldest sons in inches. If there is a significant relationship between the two variables, predict the height of the son if the height of his father is 78 inches. Use alpha level of 0.01. Okay? So we have their height of the father and height of the son. And our sample size here is equal to 10. So let us formulate the null and the alternative hypothesis. So for the null hypothesis, there is no significant relationship that exists between the height of the father and the height of the son. And for the alternative hypothesis, there is a significant relationship that exists between the height of the father and the height of the son. Next is to make table of values. So we have values for x, values for y, values for xy, values for x squared, and values for y squared. Then get the sum of each column. So summation of x, we have 659. Summation of y, 680. Summation of xy, 44,947. Summation of x squared, 43,601. Summation of y squared, 46,356. Next. Tumawag lang. Next. We have the solve for the R value. So substitute the values of each summation on our formula. So we have 10 times 44,947 minus 659 times 680 divided by the square root of 10 times 43,601 minus the square of 659 times 10 times 46,356 minus the square of 680. So we have R value which is equal to 0.95. Next is test the significance for R. So since our n is 10, it is less than 30. So we will use t-test. So t now is equal to 0.95 times the square root of 10 minus 2 divided by the square root of 1 minus square root of 0.95. And our degrees of freedom is equal to n, which is 10 minus 2, so equal to 8. So our t value is equal to 8.605. And our critical value of t, so it is a two-tailed test having 8 degrees of freedom. So on our table, we have positive and negative 3.355. If we will compare, the computed t value of 8.605 is greater than the critical t value of 3.355. Since it is greater than, so our null hypothesis is rejected. So meaning there is a significant relationship that exists between the height of the father and the height of the son. So since there is a significant relationship that exists, meaning we can do a regression analysis. So meaning we can predict the height of the son given the height of the father. So let us proceed. So the decision will be, since the computed t value of 8.605 is greater than the critical t value of 3.355, the null hypothesis is rejected at 1% level of significance. Interpretation: the computed R value of 0.95 indicates a strong positive correlation between the height of the father and height of the son. It means that whenever the height of the father increases, the height of the son also increases. The test of correlation shows that there is enough evidence to reject the null hypothesis that there is no significant relationship that exists between the height of the father and height of the son. And in our conclusion, therefore, there is a significant relationship that exists between the height of the father and the height of the son at 1% level of significance. So, since there is a significant relationship that exists, we can now make a prediction. So, let us make a regression analysis. So we need a 4 column. So we have summation of x, summation of y, summation of xy, and summation of x squared. So we have 659, 680, 44,947, and 43,601. Then let us solve for the value of the slope, which is b, and for the value of the y-intercept, which is a. So our b is equal to n, which is 10, times the summation of xy, which is 44,947, minus summation of x, which is 659, times summation of y, which is 680, divided by n, which is 10, times summation of x squared, which is 43,601, minus the square of summation of x, so the square of 659. So b now, or the value of our slope, is equal to 0.78. So we will just round it off up to 2 decimal places. Then compute for a. So the y-intercept now is equal to the summation of y, which is 680, minus the value of our slope, which is 0.78, times summation of x, which is 659, divided by the value of n, which is 10. So our y-intercept is equal to 16.60. And since we have able to solve for the slope and the y-intercept, we will just substitute the value of b and a in our regression equation. Y is equal to bx plus a. So y is equal to 0.78, x plus 16.60. And since we will make a prediction, given is the value of x, the height of the father, which is 78, and we need to predict for the height of the son. So we will just substitute 78 for x. So just substitute 78 for the value of x. So y is equal to 0.78 times 78 plus 16.60. So we have y is equal to 77.44, and we will just round it to the nearest whole number. So 77.44 is approximately equal to 77. Okay, so meaning in our answer to the given problem, the height of the son is 77 inches if the height of the father is 78 inches. So take note that this prediction is just based on the given values in our data. Okay, next, example number 3. So let us assume that the significant relationship exists between our given variables, which are the number of hours spent in watching TV and test scores. Okay, so meaning there is a significant relationship that exists, and since there is a significant relationship that exists, meaning we can predict, okay, can do a regression analysis. So the following data represents the number of hours 12 different students watched television during the weekend, and the scores of each student who took a test the following Monday. So letter A, find the equation of the regression line, and letter B, use the equation to find the expected test score for a student who watches 9 hours of TV. Okay, so we have there the data, and our n is 12. Sample size is equal to 12. Okay, so complete the table for x, y, and x squared, and then get the sum. So summation of x is 54, summation of y is 908, summation of xy is 3724, and summation of x squared is 332. Then solve for the slope. So we have n is 12, summation of xy is 3724. So we have 12 times 3724 minus the summation of x, which is 54, times the summation of y, which is 908, divided by n, which is 12, times the summation of x squared, which is 332, minus the square of summation of x, which is 54. So our slope now is equal to negative 4.07. So we have a negative slope. And then we have here a y-intercept. So summation of y, which is 908, minus the slope is negative 4.07, times summation of x, which is 54, divided by n, which is 12. So our a now is 93.98. So we have now the regression equation. Y is equal to negative 4.07x plus 93.98. So we have here the graph. Okay. So our independent variable is ours watching TV, and our dependent variable is the test score. So we have there the regression line. Okay. So our regression equation, y is equal to negative 4.07x plus 93.98. So that is our answer on letter A. Next, on letter B, so using the equation y is equal to negative 4.07x plus 93.98, we can predict the test score for a student who watches 9 hours of TV. So we will just substitute 9 for the value of x. So we have y is equal to negative 4.07 times 9 plus 93.98. So our y is equal to 57.35, or approximately equal to 57. So our answer on letter B, a student who watches 9 hours of TV over the weekend can expect to receive about a score of 57 on Monday's tests. So meaning if a student watches TV for 9 hours, he or she will get a score of 57 on a test. Okay, so that is all about regression analysis. So let me end this discussion by this quotation. According to Peter Drucker, the best way to predict the future is to create it. Okay? So, thank you so much for listening, grade 11 students. I hope that you learn a lot from this topic. So, thank you so much and God bless to all of you. Goodbye.